Hello everyone, welcome back to another video. In today's episode we're going to be discussing alcohols and IUPAC nomenclature that's associated with them. An alcohol is an organic compound with a hydroxyl, OH, functional group on an aliphatic carbon atom. Alcohols with 1 to 4 carbon atoms are frequently called by common names in which the name of the alkyl group is followed by the word alcohol. So, for example, this is methyl alcohol, 1 carbon, so methyl, and then followed by alcohol. This is ethyl alcohol. This is also the alcohol found in alcoholic beverages. Here is propyl alcohol, and this is isopropyl alcohol. Now, like most nomenclature, this doesn't deviate from what we've done before. Stick to the same roots. However, it is important to keep this list in mind. This is a list that I've drawn up. It's from my textbook. It's the nomenclature priority list. What this displays is the functional groups that you'll come across and how they rank compared to one another when deciding how to name a molecule. And so here's alcohols. And it's important to understand where it is, where it lies, compared to other things that we'll come across in the molecules that we're working on today. Because pretty much all we're going to be doing is example problems. One other thing to keep in mind is phenols, right here. These are benzene rings with an alcohol attached. And one other functional group that we're not discussing today, but something you should keep in mind because it acts a lot like alcohols, is thiols. Pretty much the same thing as an alcohol. This is an alcohol. A thiol is a sulfur atom bonded to a hydrogen. Both are electronegative, and both are in group 6 of the periodic table. We have an alcohol group. Where do we number from first? Well, this is pretty easy. 1, 2, 3, 4, 5. So this is 2-pentanol. All right, next one. So, where do we number from here? Well, alcohol groups get priority over those halogens, the haloalkanes. They fall on the same priority as alkyl substituents. So, number from here, 1, 2, 3, 4, 5. Do not make the mistake of thinking that this is a carbon atom attached to that bromine. It is not. The carbon atom is right here. This is the bond to the bromine. So for this case, this is 5 because bromine gets alphabetical priority. 5-bromo. 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 2, 2. I forgot to mention this earlier. Alcohols get the ending -ol. Pentanol. Instead of -ane, it is -ol. All right, let's step it up one notch. 1, 2, 3, 4, 5. I mean, you could say this is 6, or you could say this is 6. We'll just do that because it's the straight chain. So, on 5, we have a methyl. On 2 and 4, we have 2 alcohol groups. So, that is diol. 5 methyl. 5-methyl. 2, designate the location of both of those alcohol functional groups. 2, 4, it's a 6-chain. It's 6 carbon atoms, excuse me. Hexane, diol. The di signifies that there's 2 groups, of which they are alcohol groups. Continuing further, this one's a little bit more different. Where do we start? You can pause it and proceed, and then come back and start it up and see how I do. So where do we begin? Where do we number from? That's the first question you should be thinking. Well, the alcohol gets priority, and so therefore, this is 1, this is 2, 3, 4. So we have a phenyl. That's just benzene as a substituent. Phenyl with a P. we have a methyl on the second carbon and an alcohol also on the second carbon. So, how do we name this? Well, keep in mind alphabetical priority. M comes before P, so 2-methyl. Four phenyl. Two, because it's a 4-carbon chain, butanol. Remember, leave off the ane, switch it to an all. Alright, so with this one, what do? Well, we have a benzene ring with an alcohol functional group directly attached, and we have 2 substituents. So, obviously this is the first position. The second position on the benzene ring, we designate this ortho. These 2 substituents are ortho to one another. So keep that in mind when naming this molecule. Alright, so how do we name this? Well, we're going to have to put it in parentheses. So ortho, designate it first. Ortho, 1, 2. Attach to that second carbon, 2-hydroxy. 2-hydroxy. That's a little different. Ethyl. Because of that 2-carbon chain. Dash. Phenol. Or phenyl. However you like to pronounce it. Ortho. 2-hydroxyethyl phenol. Alright, here we go. Alcohol on the second carbon. Alcohol gets priority. All we have here is a bunch of alkyl substituents. And so they're on the bottom of the totem pole compared to this alcohol functional group on the second carbon. So continue. 1, 2, 3. On the third carbon, we have the alkene. 4, 5. On 5, we have the propyl group. 6, we have an ethyl group. 7, 8, another alkene. 9. There's our chain. Now let's name it. So keep alphabetical priority in mind at all times when doing nomenclature. Second behind the priority list. So ethyl comes before propyl. So 6 ethyl. 5 propyl. Now we designate the alkene, both of them. 3, 8. It's a 9-carbon chain, so known. N. And since there's an alcohol, you leave off that last E. So that is not there. And then we designate 2 all. And that's your nomenclature for this. A little weird, a little funky. Definitely takes some practice, so use this as an example, and then you can honestly make your own structures, and then go ahead and name them. Or just look up practice sets online. There's always a ton of them. So the last problem we have here is drawing a structure for a given name. Now, I went ahead and drew the phenol. Well, I drew the benzene ring. Here's the phenol now. And we can always designate that the first carbon. 2,6-dimethyl. So, easy. 2, put a methyl. And then the other methyl on carbon 6. And there you have it. So I hope this video helped by giving you some extra practice and some further motivation to go ahead and get going on your alcohol nomenclature. Keep in mind the priority list, keep in mind alphabetical priority, and all the other nomenclature rules that we've learned thus far. I hope you enjoyed. Hit the thumbs up button if you did, and subscribe for more content. Thank you. We'll see you in the next one.